Defrost control board for a heat pump. There are sundry of different types of manufacturers or whatnot of defrost control boards. Many operate in a similar fashion. They may be configured just a slightly different, but the functionality is pretty much the same. They're perhaps to defrost to get the ice off of the coils or the frost off of the coils. It may be time delayed. So, but we've been identifying particular parts here. So earlier we had identified the red and the C. Red incoming 24C makes the loop, the blue wire normally. Then we have the Y wire. The Y wire perhaps should energize the perhaps the cooling, or it could be used perhaps for the heat too. I'm not certain on that. The HVAC gurus can elaborate on that in the comment section. But but in order to power the Y wire up, the red and I'm thinking the red and the C wire needs to be powered up, and then it has to jumper over, and this may be done, I'm not certain, in the thermostat or whatnot, but whenever it closes. So you've got 24 volts here, then you would have 24 volts here, and then this would be the outgoing here for the, I'm thinking 24 volts on the common, the blue, the red wire, and then the Y would normally would be used a yellow wire. It's not engraved in stone, but if you could keep it color coded, but actually so that one knows it between the transformer, the thermostat, and the defrost control board. So again, to recap, we have a red wire. We have the red 24 volts, the C outgoing. That should return the voltage back, the low voltage. And when it calls for Y, which would, I'm thinking would be cooling, and in a heat pump, perhaps gas furnace may be different, but a heat pump, it may be cooling, or it could energize heat if the reversing valve, once the reversing valve is energized. So it depends on the situation. And so anyway, so we have Y, and then Y would jump over here. It would run through a sequence of operations, the low pressure and the high pressure switch or whatnot. And then at this point we have the terminals that would go out to the reversing valve, but we'll cover that in a bit. So we've had the red, the C, and the Y, and then once the Y is energized, it should go out and energize either the cooling mode or perhaps the heating mode. It depends on what happens with the reversing valve. If it's put into heating mode, it depends on the reversing valve. Then at that point, the system would, the outside unit would become like the inside unit, and the inside unit would become on the outside unit, meaning that the A coil on the inside essentially would be flip-flopped. So you would take and you would take and flip it 180 degrees. So this is kind of the theoretically how a heat pump works. It has a reversing valve that reverses the flow of refrigerant. So then the heat that you hold over your hand in the summertime, that heat would be put to the inside. So the inside would perhaps almost be like, and again, the HVAC, I'm not certain on this, the heat on the inside would dissipate that heat to help heat your house, so you're not using your heat strip, so your power bill doesn't go so high. Because once it gets to where the refrigerant's unable to heat the house, then or if it goes into defrost mode and your heat strips light up, whether it be a 5K, 8K, or 10K, or whatever K, it gets very expensive on your power bill. So your power meter will start increasing, and you might notice a noticeable difference in your power bill, say in late December, January, February months when it gets extremely cold. So again, defrost control board, terminals on a defrost control board explained. Thank you for watching. Have a wonderful day.